Okay, so today is the second lesson on indices, where we're going to take it a little bit further and we're going to look at equations where there are two unknowns. So just quick recap. If I wanted to do 16 to the power 3 as 2 to the power of something, how would I do that? Well, I remember that 16 is actually 2 to the power 4. So I've got 2 to the power 4 to the power 3, and what do I do when I have a bracket with powers? I multiply them, so that would be the same as 2 to the power of 12. 1 over 49 is 1 over 7 squared. And how do I write 1 over 7 squared as 7 to the power of? Well, that would be 7 to the power of minus 2, because when you've got your number in the denominator, you've got the reciprocal. Right, 27 to the power of x. Well, again, 27 is 3 cubed, so I've got 3 cubed to the power of x. What do I do with these indices? I multiply them, so I'd have 3 to the power of 3x. 1 over 625. Well, 625, again, remembering these powers that we need to learn, is 5 to the power of 4, so that would be 5 to the power of minus 4. And then I've got 3 more where I have to think a little bit deeper about these. So the first one, 4 times 2 to the power of x. Well, my answer has to be 2 to the power of something. So that means I need to change this 4 to begin with. And I need to think, well, 4 is just 2 squared. So effectively here I've got 2 squared times 2 to the power of x. Now, what do I do with indices when I'm multiplying two things, as provided the base is the same? Well, we add the indices. So that actually becomes 2 to the power of 2 plus x, because I add my indices when I am multiplying. Right, so now let's have a look at the next one. I've got 9 to the power y divided by 1 over 27. Well, I've actually got to think about both of these to begin with. So the first thing I've got to think about is this 9 to the power y. Well, that is 3 squared to the power y. And so that becomes 3 to the 2y. 3 to the power of 2 times y. 3 to the power of 2y. I've then got to think about what 1 over 27 is. Well, that's 1 over 3 cubed. So that is 3 to the minus 3. So I'm doing 3 to the power 2y divided by 3 to the power of minus 3. And what do we do with indices? When we divide, we take away. So effectively, I've got 2y take away minus 3. But I don't want to write 2y take away minus 3, because taking away a negative is the same as adding. So that becomes 2y plus 3. So 9 to the power of y divided by 1 over 27 is 3 to the power of 2y plus 3. Deal with each part separately. And then let's look at this last one. Well, I've got 5 to the power x already in 5 to the power of, so that's okay. I just need to think about this 125. Well, 125 is 5 cubed. So I've got 5 cubed to the power of y. So what does that become? Well, that becomes 5 to the power of 3y. Because remember, 5 cubed to the power y. What we do with these indices, we multiply them. So I've got 5 to the power x times 5 to the power of 3y. What do we do with our indices when we multiply? When we've got the same base, we add them. So it just becomes 5 to the power x plus 3y. Okay? Right. If you need to watch that again, watch it again. But then have a go at these 5. So press pause and then press play when you've finished to see the answers. Okay, so number 1, 125 is 5 cubed. What do you do with the powers? When you multiply, you add them, so you get 5 to the power 3 plus x. Right, 8 is 2 cubed, so 8 to the power y is 2 to the power 3y. What do you do with powers when you divide? You subtract them. 27 squared is the same as 3 cubed squared, which is 3 to the power of 6. 9 to the power y is 3 squared to the power y, so that's 3 to the power of 2y. What do you do with powers when you multiply? You add them. Okay, penultimate one. 4 to the power x is 2 squared to the power of x, which is 2 to the power 2x. 1 over a is 1 over 2 cubed, which is 2 to the power of minus 3. So what do you do with powers when you divide? You take them away. But if you're taking away a negative number, it's the same as adding. So you end up with 2 to the power of 2x plus 3. And the last one, when you've got x's and y's. So let's deal with the first bit. 125 is 5 cubed. So 125 to the power of y is 5 cubed to the power of y, which is 5 to the 3y. If we look at the 1 over 25 to the power of x, well, let's deal with this 25 to the power of x first. Well, that's 5 squared to the power of x, which is 5 to the power of 2x. So we end up with 5 to the 3y times 5 to the power of minus 2x. So our indices, you add them when you're multiplying. So we end up with 3y plus minus 2x. So that just becomes 3y minus 2x. So your answer is 5 to the power 3y minus 2x. Okay, so you can really see how we've pushed these rules of indices on now from GCSE. We've got a lot more algebra in there. And the final step with an indices question is to actually solve two indices equations simultaneously, which actually, if you look at these two, solve 2 to the power x times 2 to the power y equals 8 and 5 to the power x times 25 to the power y equals 1, actually looks virtually impossible. But we actually start off by thinking about our rules of indices first. And we know 2 to the power x times 2 to the power y. What do we do with indices when we multiply? We add them. So that becomes 2 to the x plus y. We can write 8 as 2 to the power of, because we know 8 is 2 to the power of 3. And just like we did in the last lesson, for this equation to be true, the only way this can be true is if these powers are the same. So we actually end up with the equation x plus y equals 3. Okay, do the same with the next one. So I've got 5 to the power x times 25 to the power y. Well, first of all, we need to deal with this 25 to the power y, just like we did before. We need to write it as 5 to the power of something. Well, that's the same as 5 squared to the power of y. So on the left-hand side of this equals, we've got 5 to the power x times 5 to the power of 2y. And if we think about what the number 1 is, this is the one where people get confused. But remember, how can I write that as 5 to the power of? Well, anything to the power of 0 is 1. So I can write that as 5 to the power of 0. So I've got 5 to the power of x plus 2y, because we're multiplying these two 5 to the powers of together. What do you do when you multiply? You add the powers, equals 5 to the power 0. The only way this can be true is if x plus 2y equals 0. And guess what? Now, we've got two simultaneous equations, because we've got x plus y equals 3 and we've got x plus 2y equals 0. Now, I'm not going to remind you how to do simultaneous equations. If you've forgotten, go back onto Hegarty Maths and recap how to do simultaneous equations. But in this case, I can see if I did this equation take away the top equation. So the bottom equation, take away the top equation, I would have y is equal, well, what 0 take away 3 is minus 3, okay? So be really careful about that. You've got to think about your negatives and your positives. I've got an extra y here, and yet I'm 3 less, so my y must equal minus 3. And then if I substitute that into one of the equations, x plus minus 3 equals 3, using the top equation, x plus y equals 3. That means my x must equal 6. And I've solved this equation. And if you want to check it out, you can check out the first one. Let's do a different colour, shall we? So we'll do this one in a different colour. So we could do 2 to the power x times 2 to the power of y. Well, that's 2 to the 6 times 2 to the minus 3, which is 2 to the power 3. And guess what? That equals 8. So that one has worked. We could try the second one. Now this one's going to be a bit trickier, but I'd have 5 to the power of 6 times 25 to the power of minus 3. Well, let's think about what 25 is. It's 5 squared to the minus 3, so I'd have 5 to the minus 6. And guess what? That equals 5 to the power 0, which is 1, and so it has worked. Right, I'll do one more example, because sometimes it can all get a little bit mixed up. So, 3 to the power x times 1 over 27 squared equals 9 to the power y. Now, we can see these are all based on 3 to the power of. So, 1 over 27 squared is 1 over 3 cubed squared. So that's 1 over 3 to the power 6, which is 3 to the power of minus 6. So on the left-hand side, I've got 3 to the power x times 3 to the power of minus 6. 9 to the power y is 3 squared to the power y. So on the right-hand side, I've got 3 to the 2y. So what is my simultaneous equation? I'm multiplying, so my powers are added. So I've got x plus negative 6 equals 2y. So actually I'm going to write that better. X minus 6 equals 2y. And that's the equation that I've created from this first equation. Now let's look at the second one. So I've got 5 to the x divided by 1 over 5 to the y. 5 to the x divided by, how am I going to write 1 over 5 to the power of y? Well, that's 5 to the power minus y, because it's a reciprocal. Let's deal with this one. Well, 25 is 5 cubed. So 1 over 5 cubed is 5 to the minus 3. So what's this other equation that we've created? Right, now be careful. What do I do with powers when I divide? I take away. So I've got x take away minus y equals minus 3. And again, I'm going to tidy that up. I don't like taking away negatives. So effectively, I've got x plus y equals minus 3. And now I have two simultaneous equations. So I'm going to write them down here. X minus 6 equals 2y, and x plus y equals minus 3. Now these aren't in the traditional form of how we would solve simultaneous equations, because we have so many x's and so many y's equals a number. But that means I just have to change that one. So I'm just going to move this so it's out of the way a little bit down here. How would I do that? Well, what would I do? I would add 6. So I'd get x equals 2y add 6. And I'd take away 2y. So I'd end up with x minus 2y equals 6. And then if I put the other equation that I've got, x plus y equals minus 3 underneath it, then I've got my two simultaneous equations that look how I would normally do simultaneous equations. So what am I going to do with this one? I'm actually going to multiply that one by 2. So I'd have 2x plus 2y equals minus 6. And I'm going to take these two equations and I'm going to add them together and get 3x equals 0. So guess what? My x must be 0. And if my x is 0, using the top equation, I'd have 0 minus 2y equals 6, because x minus 2y equals 6 using this equation here. That means minus 2y equals 6, so my y must equal minus 3. And that's the type, you can have an answer of x equals 0. Okay, it is acceptable, it is allowed. All right, so let's have a look now at 4 for you to have a go at. Again, press pause. When you finish, press play and I'll show you the solutions. Okay then, so solutions for the first question. 2 to the power x times 8 to the power y equals 32. Got to make everything 2 to the power of. Hopefully you can see that the equation you're going to get is x plus 3y equals 5, because when you multiply two bases to the power of, you add the powers. With the second one, this first fraction becomes 2 to the minus x because it's in the reciprocal. 4 to the 2y is 2 squared to the 2y. What do you do with these? You multiply. So you end up with minus x plus 4y equals 2, because again you add the powers when you're multiplying these two things together. So we've got these two simultaneous equations over here. Because you've got a plus x and a minus x, you'd add the two equations together. 7y equals 7, y equals 1, and so you end up with x equals 2. Right, next one. 5 to the x divided by 5 to the power of 3, because that's what 125 is, equals 5 squared to the power of y. So when you divide 5 to the powers of, you take away. So I've got x take away 3 equals 2y for my first equation. Second equation, 5 squared to the power of x is going to be 5 to the 2x. Times 5 to the 2y equals 1. Now remember, this is one that catches everyone out. How can I write 1 as 5 to the power of? You can write it as 5 to the power of 0. So the equation you're going to get is 2x plus 2y equals 0. So this is the equation for the second one. Now my first equation I've rearranged. So I've added the 3 and took away the 2y to make it in the form that I'm used to. Because I've got a minus 2y in the first equation and a plus 2y in the second, I'm adding them. So I should have got x equals 1. And then when I substitute that in later, I should get y equals minus 1. Right, number 3. So 4 to the power of x is the same as 2 squared to the power of x. So that's 2 to the power of 2x. 1 over 2 to the power y is the same as 2 to the power minus y. So the first equation I get is 2x add minus y, so I just write that as 2x minus y equals 6. Right, second equation, 2 to the power x divided by 4 to the power y. So I'm going to have 2 to the power x divided by 2 to the power of 2y. What do I do when I divide? I take away. So I get x take away 2y equals 0. Okay. So that's the second equation. I think I've done this one wrong. So I've got 2x minus y equals 6. I should have x take away 2y equals 0. So hold on. Oh yeah, I have, sorry. Which is this equation here. But then I've gone on and I've doubled that equation to get my number of x's the same. Okay, so take this equation from this and you end up with minus y take away minus 4y equals 6 take away 0. So you end up with y equals 2, and when you substitute that back in, you get x equals 4. Sorry, that one created that equation there. I was getting myself confused because I was looking at this one. Okay, right, and the last one, again, the equation you end up with is 3x take away y equals 1, because 3 is 3 to the power of 1, so that's that equation here. You end up with 2x plus y equals 4, which is this equation here. And because you've got a minus y and a plus y, you can just add the two equations and you get x equals 1, and then substitute that in and you should get y equals 2. Okay, so that's this lesson. It is quite a push from what you've done previously with indices. So if you need to watch it again, have another watch, but then have a little go at the worksheet on Edmodo.